Willkommen, bienvenue, and welcome back to the Modding of Isaac with Lyte. And today, we're going to revisit some old code and fix it back up because it didn't do exactly what it was supposed to. The first thing is with the putting out of fires and receiving wood from the Sticks and Stones mod. It didn't work quite right. When you would leave a room and come back, it would spawn more because the fire was dead, but it was a different dead fire than when we were first in the room. So we put in a little bit of code to fix that up. And we're going to work with beggars, because there were a lot of things that were just not right with our beggar code, because they weren't official slot machines. Unfortunately, we can't make them official slot machines in a way that really works for us. So we just counteract the detrimental effects of not being a slot machine. And so let's take a look and see how it works now. It is currently April Fool's Day, despite the video coming out on April 2nd, and we're going to continue a run using this fella right here. He's in place of the keeper. To demonstrate that now, our beggar shows up when we restart a run after exiting the game. Because, well, he had a bad habit of disappearing when you left the room, much less the game. So now we have beggar persistence, not only across rooms, but across games. So if you exit, come back, he's still there, and just the one of it. Still has the normal beggar functionality. You run into him and he takes your stuff and then he gives you things. I'm currently the keeper, so he gives me flies instead of hearts. And you'll notice our flies don't attack him anymore. That was a big problem with the original. And our tears go right through it. So we made several improvements on this guy. Oh, also, when you enter a room with him, he doesn't shut the doors. Also very important. So we're going to go through all of these improvements. If you haven't watched the Sticks and Stones episode and the Custom Beggars episodes, I'd recommend going back and watching those because they are a good starting point for a lot of the things we do with this. And there's a lot of code I'm not going to explain because we covered it in those. So go and watch those. Come right back. Okay, now we're good to go. Let's head over to the code, and where we're going to start is in entities.xml. Because in here, there's a little bit of code that we haven't used before. You can actually say whether or not an entity shuts the doors. It's really cool. So if you've got things like those spike traps, they're entities, but they shouldn't close the room off because they're just sitting there waiting for you to mess up. If you add that to your beggars, they don't shut the doors either. Would be really embarrassing if you got stuck in a room with a beggar with no bombs and they close the doors. You just can't get out because you can't kill them unless you have enough things to make them disappear on their own. So if you just add shut doors equals false, they will make it such that they don't actually shut the doors. It's great. Super easy. Don't have to go into the Lua for it. Now for the other things. Those, in fact, do require the Lua. So thanks to the various new callbacks, we add a lot of different things to this mod. And it actually highlights one of the huge difficulties in using those callbacks. So we got rid of cur room. We're keeping cur stage, though. You'll see in a bit why. We add a new variable called register. That's where we're going to register our beggars, such that when we re-enter their room, we actually resummon them. We have a function, remove from register. What this does is you hand it an entity, and it goes through the register, sees if it's on there already, and when it finds it, it removes it. It has to be the same type, the same variant, and in the same location, in the same room. All of those things have to be identical for you to remove it from the register. Using table.remove removes a row from a table. Which table? Register. Which row? J. So the one we are currently looking at. So we loop from the first row to the number of rows in the register. Goes through each one, inspects the room, position, type, and variant, and compares it to the current room and the current entity. If they match, poof, gone from the register. We use this when we explode the beggars or when the beggars teleport their own way out. We make our own function for it because we use it in 2 different places, and if we change the way this works, we don't want to update it in some indeterminate number of places. We want to replace it once. So we just say remove from register somewhere during the code, and it'll do all of this for us. If you're unclear on how functions work in Lua, go back and watch the function primer. It tells you exactly how everything works. I don't remember the number of the episode, but there is one, the Lua primer on functions. It tells you exactly how functions work and why we would do this. Then we have another function, spawn. I call it spawn register, you could call it spawn from register, but what it does is it goes through the register, checks if you are in the right room. So you compare the room in the register with game get level, get current room index. So you check if you're in the right room, and if you are, respawn that thing. So you grab from the register the type, variant, and position. Right now, it doesn't do subtypes. If you want to do things with subtypes in your register, you just add another bit of information to it, and you're good to go. For now, I don't feel the need. There are so few things that have subtypes that I would want to have registered. Then, if the thing we spawned was our special beggar, then we do the initialization. Because we don't want to wait. Well, actually, we don't want to re-add the beggar to the registry, because this is the initialization without registering the beggar, because it's already on the register. We don't need to do it again. So what this does is we set up a beggar flag. These are the entity flags necessary for making your beggar not be targeted by your flies and not be affected by poison or slow or any of those. I believe those are the only 2 entity flags that you need to make your beggars immune to everything. But again, there might be some fringe case I'm not thinking of. Then, we clear their entity flags, all of them. So we get their entity flags and clear their entity flags. So clear all of them. Then we add only our beggar flags. There shouldn't be any here. Really, there shouldn't. But just to be safe. Then we add our beggar flag to it to give it non-target and non-status. Then we set its collision class. It collides only with the player, not with enemies, not with tiers, not with anything else, only the player. And then I have a little sprite offset thing because the animation for the beggar that I took from the regular old beggar is actually 4 pixels off. He looks like he's floating 4 pixels off the ground. So I'm showing you here how to do it in the Lua. You probably should just do it in the anim2 file. You should just do it in the animation. But if for some reason you want to make them look like they're floating up and down independently of the animation, here you have entity.sprite offset, and then you give it a vector, and it shifts them by that amount. I will say one more time, do it in the animation, but if for some other reason you need the sprite offset, it is a thing, and you can use it. So that's removing from the register and spawning from the register. We'll show adding to the register later. We updated our save state function because we need to save the beggars now too. So we've still got our same old data from sticks and stones. And now we've added a little bit more for the register. We need to save it. Now, this manual 0 padding that I did, it's not strictly necessary because you can actually do a string format of numbers. So we have saved data, and then you're concatenating. So you're taking the strings, shoving them together, such that they're one string. What are we adding in? Well, we are formatting it this way. I know that looks weird. I know it's unusual, but it does exactly what you need. So you put this % saying we're doing something fancy with the next thing I give you. And then this 5U is telling it what to do with it. So we're taking the thing, we're making it a length 5 unsigned integer. I'll say that again. Length 5 unsigned integer. So integers are whole numbers. 1, 2, 3, -7, 25. An unsigned integer is one that does not have a sign. For example, the negative sign. There is no -25 in the unsigned integers. There is only 0, 1, 2, 3, 4, 5 going on up. And we only need unsigned integers because room indices are positive, our position x and y are all positive, our types are positive, and our variants are positive. So we only need unsigned integers, and then we're making our best guess as to the largest one we're going to need, because we need a fixed width if we're not going to make it comma separated or tab separated or space separated or whatever. So we're making them fixed widths. A length 5 for the rooms, because I believe we have less than 100,000 rooms. Length 4, since we have a width of room less than 10,000, or less than 100,000. Wait, less than 10,000, because we only have 4 digits, counts up to 9999. A normal room is in the hundreds. We're about 320 at the middle, so it's about 640 width. And then if we make it a double room, it'll be over 1,000. So we can't just use 3 digits. We need at least 4, but I don't think we need more than 4. Types and variants, this one is a little bit more suspect. You might need a type that's more than 4 digits long, but by the time you get up to 10,000, you've got a problem. Because 1,000 is an effect. Anything beyond that, it goes a little crazy. So we're just going to stick to 4-digit ones here. If we need to change it later, we can change it later. But what this does is it puts spaces out front of it, such that it's always a length 5 number, but it might have spaces out front. Which when you load it back in, it's really nice. It just takes it as a number, you're good to go. And so it takes all of this, puts it in save data, and then actually saves it. Then we get ourselves a shiny new callback. We've got on started here. This is the MC post game started callback. So after you start a game, it runs this. So this is when you start a run, whether it's from a save or not, and it gives you a little variable that tells you, are they loading from a save file or are they not? Great. I put a little debug string here such that we can check out later where it happens in the order. We grab the player because it doesn't give it to us. And then if it's from save, we need to load the save data. Sticks and stones is the same as before, but now we're filling the register. So we set the register to an empty table. Then we start from 5. Why 5? Because we already got 1, 2, 3, and 4. We go up to the length of our mod data because that's all that's left. We have the 6 stones and then the register. We go to the end. This is the length of the mod data. And then we go by steps of size 21. Why 21? Well, 4 plus 4 is 8, plus 8 is 16, plus 5 is 21. That's how long each entry in the register is. So we go from 5 to the length of our mod data in steps of size 21. And so we insert into our table. This is how you add things to your table. Which table? Register. Now, it might be possible to do register : insert, but just for now, we'll do table.insert register. And then what do we insert? A table that has properties room, position, and entity. Because we need to know where in the floor, where in the room, and what it is. Because this is not just our wood beggar, it's also our stone beggar, and it could be anything else that you want to be persistent within a room. And then what do we grab? Well, we get the number version of the substring from where we are to 4 things later, because it's 0, 1, 2, 3, 4. That's 5 length thing. Our room is 5 digits. Then the position is a vector, and then we grab the next 4, and then we grab the next 4 for the y value, and then we grab the next 4 for the type, and then the next 4 for the variant. So we need this part to match this part. That's absolutely crucial, that what you save is identical to what you load. If it's not, oh my goodness, you're gonna run into so many inexplicable problems. And then we spawn from the register because we've now loaded it. This part, in my opinion, shouldn't be necessary. but I'll show you later why it is. If you don't load from save, then you just initialize. I just give the player 49, 6, and 2 stones for the sake of having things to give the beggars, and we set the current stage to be the stage they're on. Good to go. Now that was post game started. Next up is on room. So we have MC post new room. So you enter a new room. Hey, you're in a new room. You do some things. Well, first we hit debug string room so we know which order things are happening in. We do the room config thing for detecting changes in the room. So when we stomp on rocks. This is just getting the initial room configuration. Now we've got 2 things here that, again, I don't think should be necessary, but they are. You need to be able to detect when they hold R, so get frame count is 1 or less. Hey look, you held R to clear the room. We held R to restart the run. We have to clear the register. All those beggars don't exist anymore. New stage detection. Again, don't think it should be necessary, but it is. And here, we're on the new stage. We clear the register. All the beggars from the previous stage, gone. This is our standard code for checking if what the code thinks is the current stage matches what the game thinks the current stage is, and then changing it appropriately. Good? And then we spawn the register, because we have entered the room. If there are any beggars that are supposed to be in that room, we should spawn them. This is the one line that definitely should be here. We definitely spawn from the register when we enter a room. And we definitely look at the room to see its current state. These 2, I don't like it, but it is how it is. So that's post new room. There is also post new level, which I'm just having debug string say level. There's also game end on game over, and then pre-game exit. Whether or not you should save on this game exit, I say save game, and I've got save state here as well. Because you're about to exit. That's when you should save. I removed the save state from when you pick up the items. Like pick up the pickups, the wood, the sticks, the stones. I removed it from there because you don't have to write to the hard drive every time they pick something up. All you have to do is wait for them to exit, and that's when you should do the save. Now, personally, I also think we should probably save here as well, because sometimes the game crashes. And you want it to save at least for the floor. So you get back to that floor, you start it anew, saving on each level is fine. That's probably a decent way to go, just in case of crashes. So there's a lot of callbacks there. And I said a lot of times, I don't think this should be here. I'm gonna show you why we need it to be there. So if we come over into our log, and come on down to somewhere near the bottom. I don't know where it is. Let's check for level. Here we are. Not sure if that's the one I want. My goodness, there are a lot of levels. Well, either way, oh, it's because I exited the game. I haven't started a new run yet. But as you can see here, wait, level is done before room. This is actually different from my other testing, where room was done before level. So, hold on one second. Let's go back into Isaac, and let's start ourselves a new run. So if we start ourselves a new run, let's do it as Maggie. So here we are in a new game. If we head back over, let's close out our log, and open it back up again. Ah, we've got a problem. 118. Ah, we never got we never got level. Shouldn't cause too much damage, but... Here you can see, contrary to that other version, room is called first, followed by level, followed by start. So you enter the room first, then you enter the level, and then you start the game. Well, that's really frustrating, because if you want to clear the register at the start of a run, it happens after you've loaded the room and already spawned your beggar. The moment you get to the next floor, you want to clear out the register again, but you're already in the room. Your beggar has already been spawned. So this order of room and then level and then start, for me, is really frustrating, because it's the exact opposite order I want things to happen in. I want start to have the highest priority. The things you do at the start of the game happens before you enter the level and before you enter the room. Level should happen before room because you're now on the new floor. You reset floor level things before you play around with the room. I don't know why it goes from small to large instead of large to small. But it's things like that that you need to know when writing your code. Because we need to have it cleared off by level. And so we have to do it in the room because the room happens first. So we do our own level detection. We do our own run start detection. Because we have to. Or else we'll have a beggar there waiting for us that we didn't summon. Like if we summoned one in the first room and then held R, there would be one in the first room. It's just no good. Okay. So that's my soapbox on these new callbacks. They are generally good. There are just certain specific interactions that will drive you out of your mind. But you need to remember, room, then level, then start. Okay, now let's actually talk about the beggar. So, this on update stuff, this is not necessarily helpful for what you guys are doing, except for here, where we have the entity fireplace. I added this one little bit, where it checks if the room's frame count is greater than 1. If it is, then it spawns the wood. If it's not, that means you just walked into the room, you didn't have time to kill those fires, so you don't get anything. This is to counteract the dead fires being respawned and giving you more goodies. It's a little hacky. I wish there were a better way, and I'll keep looking to see if there is. But this is enough to keep it from spawning sticks every time you enter the room. All of this stays the same, rendering numbers, showing the things on the screen, all of that stays the same. Now, on Beggar, we've got a new initialization section, which I talked about earlier, where you have the Beggar flag, no target, no status, if their flags are not Beggar flag. So they've just been spawned, they haven't been initialized yet. Then, I say summon Beggar into the log just so I can see things happening. We clear the entities as before, we add the entity flag before, we set the collision class as before and the sprite offset as before. Then, we grab the room index from level. Game, get level, get current room index. And we insert into the register the room you're in, the position of the entity, and the entity's type and variant. So we've got a beggar, it just came into existence, we initialize it, if necessary. If it was spawned off of the register, it already has the appropriate flags. It won't go through this again, and it won't get re-registered. So this adds it to the register, and then it's good to go. The rest is more or less the same. Actually, it should be one line different, because all of this solves all of the problems we were having, because it wasn't the behavior of taking your resources and giving you stuff that was the problem. That worked great. Now, this makes the rest of it work. There is one additional thing where all the way down here, right here, where it decides to pay you out with an actual item, that's where we remove it from the register. So we take the entity, so what we're looking at, and we remove that from the register. So if it's in that room and in that exact location, hey look, it's time to get rid of it. That's the one change in all the rest of this code from how it works. The rest is just initialization. Then there's one little bit as well down where we destroy it with an explosion. We also remove it from the register, but here it's called target instead of entity because that's what it's called. That's what we got from the function. You're passing the beggar itself. What the code calls it, it's a little immaterial. You just need to know what it calls it. But just putting entity here, that's nil. It's not defined here. Always make sure you know how your variables are defined. Oh, this right here is why it was level and then room in that other log file. When you load the mod itself, I have it run these. But I probably shouldn't. It's one of those things where I want it to do the code from up here. Like, I want it to do this stuff. But it's kind of annoying about it. The other thing is that you need to have the register being filled. You need the register to exist properly when they toggle the mod. If you don't, it'll take this and make register nil. You have to update it properly. And that's why I've got these down at the bottom. And to preserve consistency with the way they do the callbacks, we'll change the order in which they're called. So you need to make sure that your mod still works when they toggle your mod in the middle of a run. Because they can exit out, turn it off, turn it back on, and come back in and potentially cause problems. You want to be as resilient against that as you can be. That's a lot to cover in 27 or so minutes. We've got all sorts of things for making the beggar better. It's mostly initialization, making sure they get set up with the right flags and the right collision class. Setting up the register, you add things to it when they come into existence. You make sure you remove them from it when they stop existing, in whichever way they can stop existing. You need to make sure you save that when it's time to save, and load it when it's time to load. Here's the code for spawning from the register. You go through each item of the register. If it matches the room, you summon it on in and initialize it properly. Once they get exploded or cease to be, you go through the register and you remove it. I add this break here because you can only remove one thing from the register at a time. There's no sense in going through the whole register of who knows how many things just to remove one, if you find it on the second. So, that should be enough to have a fully functional beggar that you can add via the room editor. If you want to have them show up via a judgment card, if you want them to replace the existing regular or demon beggars, you need to put in your own bait and switch code. All you have to do is go over room entities, see when there's a beggar, swap it out if you want, or flag it to not be checked again if you don't. I've done bait and switch a lot of times in previous episodes. Feel free to go back to any of those and check it on out. But that's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.